Hello and welcome to Module 1, Networking Fundamentals. This is the first video for Module 1. We're going to go over Lesson 1, which is explain the role and function of network components. You can see on the slide here there are 13 lessons. So we'll try to get each lesson completed in one video. However, some of them require multiple videos. We'll split them up. But this video is explain the role and function of network components. So it's the topic we're going to cover in lesson 1 are routers, switches, firewalls, access points, controllers, endpoints, and servers. So we are going to get into all of this, but just to kind of start out, before we get into all this technology, because this has advanced where we came from, I wanted to mention kind of two things. Number one, I will be using a pen to draw and sometimes a highlighter as well. So I'll draw diagrams such as this. If you think about it, this kind of where we came from, if anyone remembers what a hub is, and I got two laptops connected to this hub, but a hub is basically a repeater, and any packet that it receives is going to send out every single one of it's just going to copy that packet and send it out to every other port. So everybody receives everything all the time on a hub. So this is where we came from. It did work, but there are lots and lots of improvements that can be made, specifically with collision domains and broadcast domains. So let's go into the next slide here. So on this slide, we're going to be talking about switches and routers. So the first bullet here, we have L2 and L3 switches. So L2 and L3, what does that mean? So that's talking about a layer. And when we talk about layers, we're talking about the OSI 7 layer model. So layer 1 is the physical layer, which you usually think of as cabling. Layer 2 is the data link layer, which you can think of as having frames and MAC addresses. Layer 3 is the routing layer. So that's where you think about packets and routing protocols and things like that. So at layer 2, um, we have a switch. This is a picture of a Cisco switch, and this is a what you would see on a network diagram to represent just a straight up layer 2 switch. The arrows just point, in just the directions either this way or this way, because switches just forward packets, um, and which is different than routers, because routers have a routing table and can make dynamic decisions on where to send a packet and some other things as well. So switches, they forward frames based on destination MAC address. So they have a MAC address table here with an entry for every MAC address they know about, and the switch port that they know that MAC address goes out on. If they receive a frame with a MAC address they do not have, they'll send it out to all ports and see what answers back, and then we'll add that into their MAC address table. This the switch gives you multiple collision domains, because each one of these switch ports can be its own collision domain. When you have a computer that's sending a packet connected to a switch sending a packet this way, the switch knows, it has a MAC address table, and it knows that the destination MAC address, let's just say, is out this port. So that packet only goes out this port, not out every single port. So that is the advantage of individual or multiple collision domains versus one collision domain that you find on a hub. The way that this switching happens, this packet forwarding happens, is through something called an ASIC, ASIC, and it stands for Application Specific Integrated Circuit. So you see where it says hardware-based bridging. So these packets are being forwarded. I'm sorry, these frames are being forwarded in hardware. Okay. And then I'm going back up to my first bullet because we talk about layer 2 and layer 3 switches. So everything I just talked about is layer 2. A layer 3 switch is basically a layer 2 switch with the functionality of a router. So everything that we're going to talk about here with routers, it's basically just adding on. So it's almost like dumping this into this to make one device that does switching and routing. But a router is a layer 3 device. And it is what creates multiple broadcast domains. What is a broadcast domain? It is a set of all devices on a network segment. So you can have a connection off of here, and you have a LAN segment. You have another interface, and you have a LAN segment. Okay, so coming out here and here, these are two separate broadcast domains. So if you have a device on here, and it sends out a bunch of, let's say, a bunch of broadcast traffic, which broadcast traffic goes out to everything in your broadcast domain. It will go out to this one. This will get it. This gateway will get it, but that's as far as it goes. The traffic over here will not get that traffic. This is a picture of a router. Looks pretty similar to a switch. And then this is the icon that you'll see on a diagram for routers. So a couple other things about a router. It can be an edge device and connects to the internet or wide area network. So if you have your internet cloud, you may have an interface going out. The router may be out on the edge going to the internet, and because it's connected to the internet, it may have an IP, an access list, ACL, applied. This is basically a packet filter. So you can permit and deny packets from a source or destination perspective. You can also permit or deny packets from a port or protocol perspective as well. So you could, let's say, permit only www traffic, only port 80 traffic going this way, type of a packet filter. A router uses a dynamic routing table to determine how to forward packets, and that routing table can change, and it will use the path with the best metric or the best score to determine how to route the packet. Sometimes it can have multiple paths. There may be multiple options, which is why the only entry that goes in the routing table is the one with the best score. Okay, moving on to next generation firewalls, NGFW. You'll see this term, NGFW, popular term right now. So we have a firewall that provides full layer 7 inspection. So the way that I think about the difference is you had firewalls and now you have next generation firewalls. So a firewall does did a lot of things. Mainly, you could have a big access list on there, along with a couple other things, but it could not. A regular firewall could not inspect at layer 7, which is the application layer. Again, going back to the OSI model. But layer 7 is application layer. Next generation firewalls inspect at layer 7. They also provide network address translation, stateful inspection. They can do virtual private networks, so that's VPN. They also integrated into them is an IPS, intrusion prevention system, which basically watches the network traffic as it crosses the network. It can report on what it finds, and it also has malware inspection. So at one point in time, you would have an appliance for a firewall. You would have one for your IPS. You would have one for your VPN, like a VPN concentrator. So you'd have a lot of appliances to do all of the security pieces and parts that you need. This next generation firewall, it's new, it's modern, it kind of centralizes all those different appliances into one and inspects at layer 7. Okay, next we're going to talk about wireless Wi-Fi. So this is a picture of an access point, wireless access point. When we're talking about Wi-Fi, we're talking about 802.11 technology. There's been different standards, A, B, G, N, A, C as well as some others. So you'll find these mounted on ceilings or walls in offices or warehouse environments, or really any environment that you need wireless in. They can have internal or external antennas. So this one actually is internal. There are antennas in here. They're just inside. External ones will stick out, and they're depending on the make and model. Will determine the number of antennas. They can act as standalone or lightweight. Standalone means that you fully configure it. It does everything on its own. You would SSH into it, remote into it to manage it. Lightweight means it's managed by a WLC, wireless LAN controller, which we'll talk about in a second. And it can act, well, it does act actually as a bridge. So it actually acts at layer 2 because your wireless client, wireless signal connecting here. This AP has an Ethernet cord that connects to a switch, and then at some point in time in your infrastructure, we're just going to say that this is lightweight. It's gonna have your WLC is going to grab that traffic, hit it here, put it on the right VLAN, and send it off to wherever its destination is. So you are bridging all the way through to your wireless controller. So next, controllers. We have 2 of them listed here, Cisco DNA Center and WLC. The WLC is wireless LAN controller, so it manages your access points. So if you're in an environment where you just need to deploy one access point, you probably don't need a WLC. But if you're deploying 100 or 1,000 or more, you might want to think about it. because you can make, with a wireless controller, you can make one change and it will update all the access points. You can deploy SSIDs to certain groups of APs, for example. And an SSID is a wireless network that you join. The next controller we have here is the Digital Network Architecture, DNA Center. This is a Cisco SDN controller for software-defined networking, and it allows you to centrally manage device configuration through applications. And more on that in a later module. Okay, two more items that we want to talk about when we talk about network components: endpoints and servers. Endpoints are end user compute devices, EUC, end user compute. So pretty much anything that an end user can type on, talk on, interact with would be an endpoint. Think about a laptop, a PC, a phone. So I have an IP phone here, a printer, etc. And then a server is usually a box that you find in a data center. So it provides a specific service that is generally consumed by endpoints. And an example of it would be a web server, an application server, DHC, DHCP, DNS server, etc., etc., etc. Okay, well that is it for lesson 1. Thank you very much, and I will see you in lesson 2.